This is the last day, last session of the last day. So I'll try to make it interesting. And I'll bring in some very interesting things here, and you will take part in the demo. So you will participate in the demo today, right? Okay. So before I start, let me ask this. How many of you are Spark users? Oh, wow, great. Okay. So I don't have to spend time in explaining what is Spark. And how many of you have used Redis? Wow, great, awesome. How many of you have used Redis streams? Not much? Fine, I'll spend some time on Redis streams and give you an introduction to Redis streams. Okay, how many, just now, all those who raised hands for Redis, how many of you used Redis? How many of you have queried Redis using SQL? It's not a trick question. You can query Redis with SQL or SQL. All right, I'll show you how to do that. So that's another interesting thing. Okay, what is my presentation today? Before that, I'm Roshan Kumar. I work at Redis Labs. I wear many hats. I joined Redis Labs about 2.5 years ago. It's a great place to work, and we have a lot of openings. So if you're interested, you should come and join us. That's a small pitch, and let me go to what I'm talking about. The event organizers asked me to put an agenda. I said, I have only one agenda. This is the agenda. We are collecting a lot of data in real time. So my agenda is to show you how to process this data in real time and get metrics out of it. That's it. So it's a very small agenda. There's only one agenda, and this will be the takeaway for today's discussion. Right? Okay. I'm starting this presentation with a demo. And in this demo, okay, before I ask that, did anybody attend my session in the morning about active-active? Okay, then you're familiar with these dogs. I use the same dogs for my demo in the morning. I'm recirculating the same dogs here. So what you have to do is, okay, this is something you have to do. I'll show you a website. And in that website, you go and you vote for the best dog. And then behind the scene, what I will do is, I'll run a SQL query which will do this. So right now it is nothing, right? I don't see any votes. In fact, I'm running this query against Redis. This SQL query is running against Redis, and you can do that through Spark. And also, I'll show how to do this in Redis itself. Don't do this on production. In production, you should use scan instead of keys. But now it's not production, so I'm doing keys. So there is nothing. So even if I, OK, once we start the demo, then you will see all the votes going to the stream data structure. And then once I start Spark, you will see a lot of things happening, and I'll write things to a hash table. So let me start the Spark engine before I start my demo. Now, this is the one that will collect data from Redis stream, and it will process all the data in real time. So this is the Spark engine. I'm doing a Spark submit. So since many of you are familiar with Spark, assume you know what Spark submit does. So I'm doing a Spark submit, and it's already running here. OK, so let us go here. Let's go back to this. So you need to get to this site. And to get to this site, what you have to do is this. So take out your, if I may request everybody to take out your cell phones and go to your browser on your cell phone, everybody, and go to bit.ly/Spark-Redis. Right? And you get this screen. It's like this. And what you have to do is, you can vote for any dog any number of times. I want to build the scale. Just imagine this can happen for 10 million or 100 million people, but still Redis stream can take it. So just do that. And let's see what's happening behind the scene. Which dog got most number of votes? Hey, look at this. I got 157 for the first. Oh, no, it's not ordered. So let me order. Order by IMG. OK, the last dog is winning. So let's see which dog wins the game now. OK, the middle one is winning. So you get the idea what's going on, right? So everybody is clicking on your favorite dog many times. And in the back end, I'm processing this data in real time. Wow, look at the numbers here. OK, you can multiply this by a factor of 100 or 1,000, 10,000 million. Still, the performance is going to be the same, or similar, rather. And that's the beauty of Redis and Spark. It's not just Redis, it's Redis and Spark. And what's going on here is I have Redis streams. So you can see Redis streams here. So if I do keys, you will see 4 keys right now. Yep, there are 4 keys, you can see. Can you read this? Is it clear for those at the back? OK. Click stream, that is a Redis stream data structure. So I'm collecting everybody's clicks in a stream. I don't want to lose any vote. So I'm collecting everybody's click in the stream data structure. And then I'm processing, and what happens then is, OK, let's see how big stream data structure is. By now, you should be familiar with Redis streams. Who can tell me what is the command for getting the length of a stream? It starts with X, L, E, N, xlen, and then the stream is click stream. I just call it click stream. Oops. Oh. So I have collected 8,000 plus votes out of this small audience. That's great. You have to clap for yourself. That's awesome. So that's a small introduction to clickstream or Redis stream. And what happens after this is I'm running this Spark engine. Oops, this already went up. There is a Spark engine, or I'm running a Spark process, and it uses something called structured streaming. I'll talk about structured streaming. And in structured streaming, that's a new thing that was introduced probably in 2.3, Spark 2.3. You get micro batches. Historically, Spark ran on just batches, some background job, batch job. But in 2.3, Spark introduced something called structured stream, and it does micro batches. So it collects micro batches. You can collect it from Kafka or some stream server. But here in this case, I have connected Redis stream. So you get micro batches, all the stuff that we put into stream. They did not come for every message. They came in micro batches, a few messages every maybe 10 milliseconds or 15 milliseconds. And as they came to Spark, Spark ran some queries. We call them structured stream queries. So you can run SQL-like queries on those micro batches, and you can aggregate. You can do a lot of things. But here in this case, I'm just aggregating and collecting the count. And then what I'm doing is, so this is what I'm doing here. I'm putting this data back to Redis. I don't have to. I can put it anywhere. But just for the sake of demo, I'm putting it back to Redis in the hash data structure. I have 3 keys here, image 1, image 2, and image 3, all starting with clicks. And what I did, I did another trick here. So any hash data structure that starts with clicks, I said it belongs to a table called clicks. And this table, so if I look at, let's say, h get all, I'll do clicks, just image underscore 1. So you can see it has key value pairs. I have a key called img, and I have another key called count. And then there is image underscore 1. That's the name. And then I have so many counts for image 1. What I did was, in Spark SQL, I said, anything that starts with click or clicks belongs to a table called clicks. And this table has 2 columns. One column is called img, and the other column is called count. So that's what I did here. And I defined the table, and I mapped that to Redis hash data structures. And then now I'm running this as a SQL. So that's what, oh, image 2 is still in the lead. OK, so we collected so many. So somebody is working very hard. That's great. That's good for the demo. That's awesome. And if I add, let's say, one more here, if I add hm set, so hm set is multiple set I can do. So let's say I do clicks, hm set clicks, and then I will do, I'll call whatever. I'll call it test image, and then first key is img. I'll call it test image again. And then for count, let's say this test image, the test dog will beat everybody. Let's put some big number here. Right? So if I do that here, you'll see that test image here. So I'm running SQL query on Redis. So this is the demo. So now I'll explain how I built this demo step by step. Fine? Any question on the demo? All right, I will go back. All right, so this is what we saw. So we clicked on this, and we saw, OK, in my picture, I have some small number. But now, in reality, I have a very big number. Let's see what's the latest here. Wow, second dog is winning. That's cool. All right. So the functional blocks. So first, let's define functional blocks. The first one, of course, is data ingest. I need to collect all the clicks and not lose any of them. So that's the first challenge I need to solve. And I need to solve. Here, it's a small audience, but you're building a big app with millions of users. You have a bigger problem to solve, but you can use the same solution. Second thing is you need to process this data in real time. So that's the second piece, and I'm using Spark in this case. Right? And then the third thing is data querying. So once you process this data, you are dumping this data somewhere. And then you have to query that data to get the results. So that is the last piece. In reality, it may not be a simple SQL query. It could be some kind of chart or something like Grafana or something that you want to see. But eventually, that's what you will do. So these are the three functional parts. And if we break that up into the specifics, I'm using Redis Stream. OK, I have a question. Since all of you clicked on it, this app must be running somewhere on the internet, right? So how do I get Redis on the internet? I was hoping somebody would ask that question. Since this is the last session of the last day, I'm OK with that. I'm using Redis Cloud. So Redis Cloud is a service, is a freemium service that we offer at Redis Labs. On Redis Cloud, you can go and you can sign up. And I'm not paying anything. I didn't even put my credit card. I'm just using the free service. Up to 30 MB, you don't have to pay anything. It's all free. And that's what I'm using. And if you create a new database instance on Redis Cloud, by default, you'll get a 4.0, Redis 4.0 instance. But you can open a ticket, and you can ask for a 5.0 instance for now. But in a few days from now, we are going to move all the databases to 5.0. We are just waiting for a few customers to agree to that. So for now, you could still get 5.0 instance with Redis Cloud. So I'm running my app on Heroku. I deployed it's a Node.js app. I deployed it on Heroku. And from Heroku, I'm accessing Redis Cloud. They're all in the same region on AWS right now. So it's pretty fast. So that's what is happening here. And I'm using Redis Stream inside Redis Cloud. And then for data processing, I'm using structured stream. I'll talk about structured stream in a while, but I'm sure many of you are familiar with that. And once I process structured stream, I'm dumping the data back to Redis. And as I said earlier, you don't have to. You can even dump this data to a file, a CSV file, or you can dump it anywhere. But just for the sake of demo, I'm dumping it into Redis. You can dump it into Redis to do many other things too. OK, and then I'm doing a data query using Spark SQL again. I'm using Spark and Spark SQL. It's pretty easy to do that. All right, breaking this into pieces. First is data ingest. This is data ingest. And what I'll do is I'll spend some time on Redis streams. Did anybody attend the training on Redis streams day before yesterday? Good, good. So you already have a good overview. Itamar covered in great detail. But here I'll cover at a bit higher level. So Redis streams, basically it connects producers and consumers. But in reality, you'll have many producers and many consumers. So here we saw that you all were clicking, but still I have only one app running. And there's only one producer producing to Redis stream. And I have only one consumer here, which is one Spark engine. But in reality, you can have many producers connecting to many consumers. And Redis streams supports synchronous and asynchronous communication. So, or I would not say synchronous and asynchronous. It's synchronous or asynchronous communication and look-back queries. So you can do both. Okay. How many of you have used PubSub in Redis? That's good. What about list data structure? Okay, and then sorted sets. Okay. I want to spend a minute to compare Redis streams with PubSub. In PubSub, it is fire and forget, and there is no persistence. So if you lose connection, you lose all the data. But it is good for some use cases where it's OK to lose data. You're just listening to some conversation. Even if you are offline for some time, it's OK, that kind of use cases. And it doesn't have any look-back queries. It's all asynchronous. Right? And there is also list. I'll spend some time on list. Now, list, you can do data ingest. You can connect producers to consumers using list. If you see the picture here, if you have many consumers, you need to have so many lists. So one list cannot, you cannot use one list for all consumers. So every consumer pops something out of list, and a producer should know how many consumers are there, and it should push data to every list for a consumer. And you get persistence, so that's the advantage. And you can also make blocking calls. You can do a blocking pop call, but there are no look-back queries. And if you have too many consumers, you end up making too many lists. Sorted sets, that's the third thing. It solves one of the problems here. You don't have to have a copy for every consumer. You can just have one list here. Now, the problem here is you have to always poll for data. In Redis 5.0, there is a blocking call, but blocking call transforms a sorted set into list. So that's not really helpful. You're removing data, so that's not what you want. So if you want to use sorted sets as stream for streaming data, you have to poll, which may be good in some cases, but not really a good one. So Redis streams, it solves all these problems. It addresses all these limitations that were there in the traditional Redis data structures. And another thing is, if I find time, I'll do that. You can do lifecycle management. If you have many consumers, and if one consumer goes down, and if it was in the process of consuming data, you can have another consumer take that data, claim that data. So you have all these life cycles. And also, you have built-in support for time series. And there are many things. You can connect many consumers of many kinds. If producers are very fast and if consumers are slow, you can match the rate of at which the producers push data, and you can scale out on consumers. You can have many consumers who consume exclusive set of data. And also, there is no limit there is no time limit, or there is no data retention built into Redis streams. If you look at Kinesis or Kafka, by default, there is a retention period. I think on Kinesis, it's a day, or sometimes even if you have premium service, it is 3 days. And after that, your data is gone. But in Redis streams, you don't have that limit. You can keep data as long as you want. But if you want to cap, you can cap by max length. We have a cap. You can cap for whatever size you want. OK, some benefits here. If you have different types of consumers, and if you have one set of data consumed by many consumers, that's perfectly fine. That's what this is built for. So in this example, I'm using the same data for messaging analytics, and I can back up this data and dump it to some cold storage. So I have many consumers working on the same set of data, and this is perfectly fine. And this is an example where the producer is producing faster than a consumer can consume. And we need to scale out consumers. And if you have just one consumer, you'll have a backup of data. It's like going to a toll booth. And if there is only one toll booth, as it used to happen on Golden Gate Bridge many times, I'm sure many of you have encountered this. It's a very painful experience. So that's what happens here. But with Redis Stream, what you can do is you can have multiple toll booths, and you can send each car to a different toll booth. So that's what we are doing here with consumer groups and different consumers. Right? We are matching the rate of arrival to the rate of departure. And you can have a very large use case where there are many producers producing to a stream, and you can have many consumers, different kinds of consumers, consumer groups, many consumer groups, a combination of all, thousands of them working on the same set of data. So that is the complex scenario you can think of. Okay, that's the example about Redis. That's an introduction to Redis Stream. And what I'm doing here, going back to my example, whenever we click on the image, I'm just running one command called xadd clickstream. Clickstream is the name of the stream, is the key name. And I'm doing star because I don't want to put a timestamp myself, or I don't want to give an ID myself. I'm letting Redis do that. And I'm having some key value pairs. In this case, I'm calling it img is the key. And I have 3 IDs, img, image 1, image 2, and image 3. So I'm dumping that to clickstream. So in my example, when I did an X range, this is how it looked like. I have the timestamp. This is image 1, and I just have 1 everywhere, just for the sake of example. So this is all about data ingest. Does anybody have any question on data ingest? Okay, before I go to the next section, let me see what's going on here. What's the latest count? I'm just curious. Oh, wow, we have hit 13,000. Oh, they're going neck to neck. Wow, second image and first image. Let's see who wins. So that's cool. That's very cool. Okay, I can delete test image. I don't need that anymore. So what I'll do is I'll go back here, and then I'll just delete clicks test image, so that I don't want to be bothered by this anymore. Okay, there is an undefined. Okay, maybe there's something that's still. Okay, let's wait for some time and see what's going on. Yeah, Spark sometimes it caches everything in its own stuff until it takes them out. So maybe that's what is happening. All right. So that is our data ingest, and data processing is the second part. And for those who are new to structured streaming, many of you are familiar, so I'll run through this real quick. Structured streaming, it provides, okay, this is a marketing definition. It does a lot of things. So if you go to their website, this is what you see on Databricks. It's very overloaded. So let me go to what actually it is. If you have a source, if you have a data source, what structured streaming does is it pulls data in micro batches. And after it pulls data in micro batches, you can perform all these operations and many more operations, or a combination of these operations. Every micro batch has rows, and each row is like a data frame. So you can run data frame operations on these micro batches. So you have a select operation, a filter operation, or you can do group by. In this case, I'm doing group by. Or you can even have some windowing techniques. You can have a window. You can create a window to know, I want to aggregate for the last half an hour, or you can have a moving window too. So you can do such things. And also you also have some specialized functions, like you can deduplicate something in the micro batch. So finally, in the final list, it just does a deduplication of everything. So Spark does a lot of things. So if you go to their website, they have a list of things you can do. These are just examples. So these are all the operations, data frame operations you can do on micro batches. Earlier, you could do all these operations on large batches, but you can now do them on micro batches. In the next release, or right now in 2.4, Spark has released something in experimental mode. It's called continuous processing. So what it does is, instead of getting a micro batch, this micro batch is now even smaller. Maybe I don't know what they call it, but it's even smaller than that. And you get data frames in microseconds, not in a few milliseconds. It's even smaller than that. And you can do more. You can do with sub-millisecond latency. You can process data in sub-millisecond latency. But that's still in experimental mode. But in the future release, it will go GA. Right. And finally, you can define an output sink. And you can dump all your data to your output sink. And if you don't want an output sink, you can just put it on your console. That's also available. And even here, there are different modes. You can dump everything, or you can have append only, or you can have update-based sync. So you have three modes that you can dump data, 3 ways to dump your data. Right? Any question on structured streaming? Okay, and this in fact is structured streaming. It's pretty straightforward. Now, to support all this, at Redis Labs, we have a library. We sponsor this library. It is an open source library, but we sponsor it and we develop it and support it. It's called Spark-Redis. It's on GitHub. So if you just Google for Spark-Redis, you can find the GitHub repository, and you can download. That's what I used to connect to Redis streams, and also to dump data back to Redis, and also to query Redis through SQL. So I used the same library to do all of that. So I use this library as a data source and as a data sink, and it supports resilient data sets, distributed data sets, and also data frames, structured streaming, and everything. It's all written in Scala. Right? If I have time, I'll walk through this. I'll show you more about this library. Now, how do you use Redis streams as a data source? There are 4 steps. One is you have to connect to Redis database. And the second thing is you have to map your Redis streams key value pair, the names, everything, to the micro batch. You have to map it and tell Spark, these are the names, and this is how I interpret these keys and values. And then you have to have a query object. You have to query that micro batch. So you have to create a query object and then run that query in the loop. It's very straightforward. I'll show you. All these things are done in less than 20, 30 lines. So this is the code, actual code. I can even show you the code. Let me see. So this is all the code it is. So this is one file, and I have another for each writer. So this is another file. There are only 2 files, and it's pretty straightforward. I did a copy paste of that program here. At the top, I'm connecting to Redis. In this case, I'm connecting to Redis Cloud, the database on Redis Cloud. But in this screenshot, I connected to a local host Redis. And this second part is where I am interpreting the stream data. So stream, I call it click stream. That's the key name. And if you remember, I had a few key value pairs, and I called the key img for image. So that's what I'm telling here. So this is how Spark is interpreting structured stream or stream data in Redis stream as a micro batch. And then I'm defining the query. So this is the query definition. I'm doing a group by image, and I'm doing a count. I'm doing a group by count. And finally, I'm just scrolling up. I'm dumping this whole thing to something called a for each writer. I'm doing a custom for each writer. And in that, I'm dumping things to Redis. And this is what I'm doing inside for each writer. So I have a process, and here I'm just doing, for clicks, I'm creating a new hash, and I'm doing an image and count. So this is going in like this. You can see it here. So these are all the hash data structures, and I'm interpreting this hash data structure as a table eventually. Fine. Okay, let's go back to our demo and see what's going on. Who is winning? Oops, I created something else. Something is playing around with my data set here. But image 1 is winning. That's cool. That's really cool. Image 1 is winning here. Let's see who will win. Going back. So any question on the second part, the data processing part? Okay, last part. It's the easiest of all. Here I'm querying data. The data is in Redis. I'm using Spark SQL. So how do I use Spark SQL to query Redis data? And another beautiful thing here is if you have ODBC connectors, you can connect your ODBC drivers to Spark. And if you have data in Redis, you can run SQL queries on Redis. It's very easy. OK, the first thing is you have to initialize the Spark context with Redis. Of course, you should tell Spark how to connect to Redis, right? And then you have to create a table. You have to tell Spark, hey, Spark, create a table with this name and map this to this hash map. And these are the column names. And map these column names to the names that you have in hash map, the key value in hash map. And then run the query. So that's what we are doing here. So these are all the steps. You'll get the slide deck. It is very easy. So first thing is I have to create a Spark context connecting to Redis. And since I have Redis Cloud, I'll have a URL to connect to instead of localhost. And then I'll have a different port. And also I'll have a password that I need to give to connect to my cloud instance. And then I have to import a couple of things. And in some cases, you don't have to import. I've seen that if you use 2.4 Spark, you don't have to import it. It imports automatically. And then you have to create a table. So if you have to create a table saying, if it doesn't exist, create a table. And these are this is the table name, and these are the columns. And this table is mapped to a hash called clicks. And then I have to mention that since I'm using Spark-Redis Library. So I'm telling Spark to use Spark-Redis Library. It's already in the class path. I have loaded that in the class path. And that is the class name, org.apache.spark.sql.redis. And I'm telling that to use clicks. Anything that has the key name with clicks, it belongs to this table. Fine. And then once I do that, I run the query, SQL star from clicks.show, and you get the count. Right? So OK, before I do a recap, let's see. I'm just curious. OK. Wow, image 1. The first dog is winning by a big margin. OK, that's cool. That's awesome. Now, any questions so far? Oh, 1 second here. We'll bring a mic.
Would the same statement that you outline run inside of Spark SQL, or it's only inside of Spark?
This runs on Spark SQL, and it's same as Spark.
I'm just making sure. Yeah.
Yeah. You can run a Spark SQL command instead of Scala. You can go to Spark SQL and run this. You have to create a table and map it to Redis. And when you load your Spark, let me see. I'll come out of this. Let me come out of this. So all you have to do is in the Spark shell, you can see this. You have to have these jars in your class path. So in this case, I built the Spark-Redis library on my local machine. And I'm just using that, the Spark-Redis library with all dependencies. And this has everything I need to connect to Redis through Spark. But instead of Spark shell, you can run Spark SQL with the same jar files. All you need is Spark-Redis library in your class path. Does that answer your question? Right. Okay, now I'm going back. All right, let's recap what we did. We did this demo, and the demo did not fail, so that's something to recap. It worked. And then we talked about these functional modules or these components. And also we talked about Spark-Redis Library as a data source for Redis streams and also as a data sink. We use Spark-Redis library to make Redis a data sink from Spark. And also we use Spark-Redis library as a data connector to get data frames to read all the hash data structures as data frames and run SQL query on Spark SQL. So that is the gist of this presentation. If there are any more questions, I can take them. If not, I can go back and see what's going on. Okay, so let me see if this runs. So select, I have already created the table, star from clicks, and then I have to do .show. If I don't do .show, it will just load the data frame as a variable. Okay. It's taking a long time. Okay. All right. So let's see why we are getting these spurious elements here. So if I do keys, I'm sure somebody has gone in and added those keys. It's fine. It's perfectly fine. There's no problem at all. So I have clicks cat. So let's see. Let's do an htgetall. Clicks cat. Okay, you can do this. So if I do a delete of this clicks cat, so let's say I did this, and if I run this here, that would have gone. It's gone, right? So somebody has also created undefined and Redis streams as here. And if I do an xlen on click streams, oops, click stream, it's not streams. Yeah, I have 57,000 plus data. So that's how much I have in Redis streams right now. Right? Any question? I'm more than happy to answer any question. Yeah, there's a question there.
Can you talk about a few failure modes or failure scenarios and what happens under those conditions? Like, for example, if the Spark and the Redis instances kind of disconnect and then come back,
Yeah.
like would it resume from where it left off, stuff like that?
Yeah, that's a very good question. That's a very, very good question. So the way it works is, in reality, when you run Spark, you can run multiple jobs. You can, and also you can configure Spark to fail over. And Spark, the way it works is you submit a job and it finds a slot to connect, to attach itself to, and it runs there, and it's completely fault tolerant. And if that fails for some reason, the master would know that that has failed and it will spawn another job. So that's completely a Spark configuration. But from Redis streams point of view, it's just collecting all the data, and Spark will just continue collecting data from where it left off. For example, we just disconnected, right? So let's say, that's a very good question. I'm very glad that you asked it. Let me see. So here, we disconnected everything, and again we reconnected. So if let's say I get disconnected here, I'm just stopping the Spark job. It's taking longer than it takes. Okay, it stopped. So now I can still be collecting data here. So we can still. So I can still vote and add more data to my Redis stream. Right, so I added more data. So when I restart, it always starts from where it left off. that is one of the features of Redis streams. So in Redis streams, we have consumer groups, and consumer group has a command called x read group. And you can have many consumers, and you can always tell consumers to consume from where it left off. So that is what we are using here. And you can configure Spark to run so many jobs, so many batches, so many continuous processing batches or structured stream on multiple engines, and you will not have a failover at all. Does that answer your question? And also, since we are in this use case, since we are aggregating data, you can run 100 jobs, and your final answer will still be the same, because we are adding up everything. Right. Any question? All right. If there are no questions, let's see what's going on here. Oh, somebody reset everything. OK, that's fine. No worries. Somebody is playing with the system here. That's perfectly fine. Yeah, there is a question there. Yep, we are coming there. 1 second.
Hi, I'm actually not familiar with querying Redis with SQL. Could you explain some of how that's running and working? Like,
Great.
I know you're doing aggregations on this instance. As an example, most of the time you don't want to run aggregate queries on something that's running live. Like, if you did enough aggregate queries, would that bring like the individual queries down?
No.
Yeah. Like, how's it working?
So in this case, I'm running aggregate queries on micro batches. I'm not running aggregate queries on Redis, even though Redis data is very small. If you look at what I'm doing here, going back, I'm getting micro batches from Redis stream. So I'm running aggregate queries only on those small micro batches. It's very small data set. So I'm not running aggregate queries on a very large data set. So that's one thing. There are two sides to your question. The other side is so that's happening on this side. But on the receiving side, on the querying side, I'm not running any aggregation here. I'm just doing a select star from click. And here, I assume your question is, how do we connect to Redis using SQL? How do we run SQL? Let me show you. So I'll go back here. If you Google, let's say, Spark Redis. So there is a Spark-Redis GitHub repository. So you can go to Spark-Redis GitHub repository, and it's all very well documented. It supports Spark 2.3 and higher, and you can see all the documents here. And we support RDD, data frames, streaming, structured streaming, and many other things. And in this example, I'm using structured streaming. I'm connecting to Redis streams via structured streaming. And I'm using data frames to capture Redis hash, or to interpret a Redis hash as a table. So the way I do that is, again, it's all documented here, but going back here, I have to connect. Let me show you this. I have to create a table. First of all, I have to start a Spark session connecting to this Redis instance, and then I create a table. And in this table, I'm saying create table if not exists clicks. So that's the table name, img and count. And this maps to the keys of hash. So if I do here keys star, and these are all the hash data structures. So if I do h get all clicks image underscore 1. So I have img count, and if I do this for image 2, you'll have the same set of keys, but the values are different. And all the hashes here, they all start with clicks colon something. So what we are doing is we are mapping SQL to the hash data structures, hash keys, which start with clicks, and we assume that they all have the same set of keys. And if they don't have same set of keys, you'll get an error in the table. You have a follow-up question?
Yes. So just so I understand it correctly, as an example, let's say we add a feature to this app that you created so that users can submit their own images. And now the number of like image underscore a
Yep.
million.
Yep, that's true.
You could construct a SQL query that like select number of images. Now you got effectively a select key star that would block your Redis instance. Like you could construct a SQL query that
Yeah.
runs poorly on the Redis instance.
Yeah, got it. Once again, that's a good question. So what's happening here? If you just break it down, there are a couple of things you can do. You can have a where clause and you can filter. That's one option. Let's say you don't do that. That's also okay. So when you do star from clicks, your Spark engine is running Redis queries. So it's doing hgetAll one by one. And it does a pipeline, and then it does hgetAll one by one. And it is not taking up the whole CPU cycle on Redis. So it runs hgetAll inside a pipeline. So it just does one thing. It's not a transaction. It is an hgetAll read query. You can run more than 1 million read queries or write queries on a small instance of Redis easily, more than 1 million per second. So you're not really hogging the system. And this aggregation happens on the Spark side. So there is Redis here, and there is Spark here. So your Spark engine, it gets everything, and it does aggregation. So it's not running on the Redis side. So Redis is still hgetAll. So you're pipelining, and you're running multiple queries. So you're not hogging Redis system at all. Does that answer your question?
Using scan? Is it using scan? Because that would be the way,
No.
that's the proper way to.
Yeah. Internally, that's what we are doing. We are doing scan, and then we are paginating. And so while we paginate, what we do is we do pipelining. So we do a pipeline query. So that's what Spark-Redis Library does. So if you read Spark-Redis Library, that's what it is doing. So it does a scan. It does paginates everything. And once it gets all the key set, it will run a pipeline and get all hgetAll, and then it aggregates on the Spark side. Does that answer your question?
Yeah. Okay. Yeah. Thank you.
Sure. Any other question? Yeah. Thanks for staying for this session. And if you have any question, my name is Roshan, and my email address is roshan@redislabs.com. Oops, it went away, but my email address is still there. It's roshan@redislabs.com, or you can tweet me at Roshan Kumar, my first name, last name. Thanks everybody.